Hi there, and welcome to another episode of Harrison Hobbies. Today we are going to be looking at a 1200 watt 20 volt transformer that we can hopefully power some Milwaukee tools off of. So before we jump in, I wanted to apologize for this video taking so long. My shop has been used for some cabinetry that I've been building for my kitchen. The cabinetry, at least for the first phase of my kitchen remodel, is finally done. So the shop's cleared out. A special thanks to Alan. Alan and I had talked for a little while regarding finding a solution that was better than those Lenovo power bricks that I was using. It would hopefully give us a little bit better oomph so we could power some of the larger tools. So what may help also understand kind of what we're targeting here is a previous video that I did tested the wattage of a bunch of tools. So I used this little test rig here. This gave us some real-time current readouts so we could kind of target what size of power supply we'd need. Based on those findings, the miter saw was the heaviest draw, and it came in at around 1200 watts peak and around 800 watts continuous. So we knew that we needed something that was at least 1200 watts. And thankfully this thing came in here at about 1200 watts, so it says on the website, and it costs around $100. This brand of this one here is Michelin. I think it's a Chinese vendor. Amazon doesn't have this listing anymore. Whenever you try to follow the link, it goes to the uh-oh warning. So I will, after this video, try to find an equivalent one that's for sale, either maybe on Alibaba or Amazon, and I'll get it linked in the description. So if you want to also replicate what we're doing here, you can do that as well. So our game plan here is going to be a quick unboxing here. I haven't really opened this up yet. I'm pretty sure it's just the transformer. And then we're going to build an extension cord. If you watched the previous video, I didn't have enough cord. And so every time I do anything, I was knocking cameras off. I was sitting there, I think I had maybe a foot to play with. So we've got some 8-gauge wire here that'll hopefully carry some current quite a distance. I know that I think we're going into a 12-gauge here. No, this is a 14-gauge in our adapter. So things are gonna get toasty. We'll see what happens. And once we're done with the extension cord here, then we will wire up the inverter here. Again, there isn't really much to wire. We'll just probably take an old power supply cord, cut it off, and then screw it down to the terminals, and then have the out feed going hopefully to one of these XT60 connectors. And so we can plug it in. That way we keep with the same ecosystem here, so we can plug in inline watt meters, do whatever. And then lastly, we'll go out to the shop and we'll test the inverter, see what happens. And before we get started, if you could click that like button, that will help put this video closer to the top. I think, based on the comments I'm seeing and what I've read on Reddit, this information appears to be relatively helpful. So we want to make sure that we can get this in front of as many eyes as possible, get some more feedback from the community here. And again, don't hesitate to leave some comments. I'm happy to answer any questions, try to give you some more feedback, or help you troubleshoot if you're having issues. And one thing I do want to say, based on my conversation with Alan, in case you watched this before you've started any projects, if you're building one of these, if you go back in time to the first video that I did in this series here, there are some tabs at the front of this whenever you start snipping off the 18650s, and those tabs, they're the forwardmost ones that you need to solder the inputs to. If you do it not on the very front ones, then you're just going to be hitting the battery rail and it's not going to do anything. So make sure you look closely at the video to see where I'm soldering, and if you have any questions, again, comment below. But let's take it away. So we've got our Michelin power adapter here. Let's open it up. So if we pull this out, we can see an aluminum shell here. Got a big beefy fan at the back, and then we've got our connections here. It looks like we got a little bit of damage here on the adjustment for our AV+. I'm assuming that is going to modify our voltage. And then we have a thank you letter here. Dear buyer, hello, thank you for purchasing our product. Please verify that the output voltage is consistent with the input voltage set by a power supply before use. If the input voltages do not match, the power supply will burn out. So that's just saying we've got our little voltage selector here. If we look there, that's standard, like old ATX power supplies have this. If it's over this side, it's at 120 volt. If it's at the other, it's 240. It just bypasses some electronics in here that step it down. So while I'm holding this right here, what we're going to do is, I believe we're going to be taking our input and we're going to be hooking one line into L, one into N, and then we're going to be hooking up our ground here, and then we'll look at what the color coding is for that. And then in theory, we should have probably 3 voltage rails. So I don't see any schematic here to see if we bridge these, kind of like an audio amplifier where, you know, each one of these might be a few hundred watts and we have to bridge. And then lastly, this is the, I think, the adjustment potentiometer here. But we'll adjust that until we get on the rail here the correct voltage. So the first step we're going to do is take our cable here. This just happens to be a standard computer power supply cable here. So we'll lob this off here. And that should give us our 3 cables here wrapped in. And as we had talked about previously, based on a quick Google search, we should be L will be our black. So if we've got our 3 cables here, we've got a green, a white, and a black. Our green is going to be our earth, or our ground. N is going to be our neutral, which is going to be white. And then our black should be our L. So we'll try that and see if we need to mulligan here. Okay, so as we'd said here, we have an L, which is going to be black, an N, which is going to be white, and an earth, ground, which will be green. Okay, got our green here. There we go. So we've got that. Now, when we do our testing here in a second, we're going to need to be very, very careful since these will all be hot. And if we touch these, we're not going to have a good time because things could be getting crazy. Keep our fire extinguisher right here. I did not know that. It has auto on whenever you plug leads into it. So start out by turning the screen on. We don't care about that, we care about voltage. So let's plug it in and we will see what happens. Okay, so apparently the fan has 1 speed and that is on. But if we look here, we got a little green light to indicate that we are live right over here. And it seems to be properly going. Now, one thing I do want to note is a 20 volt circuit does not, in theory, have enough potential to electrocute you. It may give you a little bit of a buzz, but it's not clamping force like 120 volt AC. And so on that note, if your hands are wet or something, that reduces your resistance, so it allows more current to travel through you. So if you perspire a lot, or if your hands are wet, or if you're hanging out in salt water trying to do this, not advised. But realistically, you don't have any real risk with your 20 volt terminals here. So just in case you're a little trepidatious on that. But let's hook it up here. So we got we'll do the 2 that are closest to each other, which if we look at the little plastic window here, that's going to be, we've got 7 and 8. So we're right at 18.2. So that would be the equivalent of a somewhat dead battery. So I feel comfortable with that. We'll unplug this. We'll allow the capacitors to drop. So we just tested this. We found that we're at a reasonable voltage here. The next step is going to be creating our XT60 connector that's going to convert this into a female or male, whatever style I have. I don't remember what I did. And so we'll be able to connect that to just kind of a stubbed out end, and then we're going to build ourselves an XT60 extension cord out of the wire right here, out of our 8-gauge wire. And then finally, that 8-gauge wire, in theory, we'll be able to plug into this. Once we get that hooked up, we'll be able to go out to the shop and try it out. So let's get soldering. Every video that I've done in the past, I had that really, really crappy like stick-on helping hands. So I think whenever I was still in the upstairs bedroom, not relegated to the basement here, I got this and haven't had a chance to use it yet, so I'm very, very excited. Honestly, now that I'm looking at this, I'm not even sure that we will, that we're going to have enough space on our XT60 connectors to accept this. I mean, that is some thick core. So what we saw on here, we had all these pluses and minuses. So we'll start it with our baseline so we don't blow this up trying to pull way too much, and we'll have all 3 of these. Actually, we won't even need that. Do Do we want to splice them, or do we want to have them all feed into the same? This cable is going to be way too thick to try to solder them all, will it? We'll make it work. We're gonna play it by ear here. We're gonna cut ourselves off a few pieces of this wire here that are going to be, I don't know, a foot or so long. And then, wow, I think these are 10 feet long, so we're gonna have a nice long extension cord here, hopefully capable of carrying enough current. Otherwise things are gonna get rowdy. Okay, so we've got still a ton of extension cord left. So we're good on that front. Then we'll spend some time stripping. I've had that inverter now for months and just haven't done anything with it. And now that I'm going through here, wish whenever I bought this wire off Amazon. And again, this siliconized wire, super easy to work once you've already got it kind of worked out, because it's thousands and thousands of little strands. So it should have relatively good current carrying capability. The wires have so much compliance that even after you kind of get them staked in or whatever, they're just so loose and flexible that they try to always let go. So we've got all of these here. So these are all going to go together. Sorry, we're going to have a plus, all the pluses together, and then we're going to cut actually one final piece here so we can have just a regular old extension cord. We'll cut this one to be maybe a tiny bit longer. Let's go to right here. Okay, we've got our stunner shades back on. If you look here, we've got the 3 wires that we're going to be hooking up to our 1 wire that's going to come out as kind of our XT60 connection. So what we'll do is there's like legitimately like an inch of wire here. I don't think we're roast compliant here. But overall, I think we're in business here. So we've got our extension cord all soldered up. So male and female on here, hopefully right polarity. And then we have our squid right here. So we've got all of our terminals here. And that again goes into one piece that we'll plug directly in. And ultimately, once the extension cord's in line, they'll all come right through. So now that we've got this, I'm going to go grab a vacuum. I've got little shards of this wire everywhere here. So we're going to try to get that cleaned up. And then we will attach this to our power supply, do a quick test with our sacrificial drill here. I finally upgraded to brushless, so now we've got one to burn through. And if that works, then we'll head over to the shop and try that out. Okay, so we just got our area cleaned up here. And we now have our power supply. We're going to take our squid. We're going to cut these down a little bit so that we're not trying to shove as much wire into here. I feel silly for having purchased such thick wire since, it's obviously not ever going to, nothing in here is sized to be able to handle an 8 gauge. And realistically, 8 gauge is probably about the size that you would want. But we'll go into a quick fast forward here. all of our positives here nice and tightly wound. So if we recall from earlier, we are negative, 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 positive, positive, positive. So what we'll do right now is we will unscrew our 3 positives. And we will feed one of these into each. Now, theoretically, well, they're all spliced together, so it doesn't matter. But even if we got kind of weird, because these, theoretically, I would expect the negatives to be on a common rail and the positives to be on separate rails. I don't know if that's necessarily true, as I haven't gone in. I didn't look at any manuals for this either. But because we're splicing them all together, it doesn't matter what's connected to positive and what's connected to negative. So we got this thing cinched down on all 3 of our negatives. And we'll do the same thing for our positives. So now we have our 3 positives. Same thing for the, same thing as we said for the positives here, is it really doesn't matter where you hook these, because they're all going to the same spot eventually. And our last one goes here. Okay, so we're back with some electrical tape here. This may not be necessary, but since all these wires are kind of close together, I don't know if there's going to be a lot of strain or anything on this, so I figure might as well just kind of tape the positives together and the negative. Again, based on the form factor here, this doesn't seem like the kind of box you'd want to be moving around a lot. So I have a pack out that I think we may end up trying to put this into. So that probably will be a next video though. Okay, so as you can see here, we have the group of 3 wires here of each branch is going into a negative line, and the 3 of the positive are going into a single positive line, and that's going to give us 1 XT60 out. Using this current in hindsight, probably should have used around an XT80, I think are the biggest that they get. And I thought I was going to be with one of those 80 or 100 watt or whatever the Lenovo power supply was. I never envisioned going up to something this big. And honestly, I never thought I would have to. But let's see what we've got going on here. So we'll plug it back in. Got some power. And let's take a voltage measure of the output here and make sure that one of these isn't sneaking in something super high voltage that would, in theory, fry one of our tools. And we'll go negative and positive, and I'm seeing 17.18, 18.2. So here we go, for anyone curious. 18.2 volt on here. So I think we are ready for some science. So here's the moment of truth. Let's zoom out a little. So we will plug this in. Whoa, that popped. Ah! That seems to be going just fine. No concern there. And you can see we've got the 2 red lights there. So let's take it out to the shop and see what happens. All right, so we're out in the shop now. I'd started making a video and I don't think I ever completed it. But we had 3 power adapters here. These were the, I want to say they were 100 watt each, maybe 300 watts, somewhere between 250 and 300 watts. We had kind of a squid that I was considering reusing here. I never got around to making that video, even though I tried to see kind of what tools. So if you guys are interested in seeing what runs on that setup, I actually ordered another 2, so I've got 5 of those, so we can be somewhere in the range of 450, maybe 500 watts. So if you're interested in seeing that, it's, again, much cheaper. I think those are like 10 bucks a piece. So that right there is 30 bucks instead of this being closer to 100 plus all your gear. This thing's probably closer to 150, maybe even 200 bucks all in. But we're out here, and I think now is going to be the moment of truth. We've got the Milwaukee miter saw. I think this is the 10-inch. And we've got our box here. So I'm not going to make a whole lot of cuts, only because I use a Canon XC10 to record with. And because it does high bitrate 4K only, it's got a fan in the back. If I don't have the fan on, it overheats. But I don't want that fan ingesting a bunch of dust here. So we will keep recording to a little bit of a minimum. But let's see if our extension cord is going to work here. So this gives us actually quite a bit of slack. But you can see kind of the misstep here. This is the wire that we probably should have been using. I think this is a 14 gauge. And this is the 8 gauge that we've trimmed down. So you can see the difference here in terms of thickness. The little bitties versus pretty hefty. But we'll plug these two in. Now, whenever I tried using the drill a little bit earlier, it let out a pretty big pop whenever I plugged it in. So we will be hooking it up to the saw and then powering it on, and hopefully that will avoid that issue in the future. With an extension cord, didn't hear pops, the saw is not smoking, got a fire extinguisher right over there. So now is the moment of truth. Oh, it started, it started. That is great news. Let's see. Oh, we made a cut. So I think this is going to be pretty feasible. I think that this is actually, it's going to be pretty awesome. So let's just do a couple of cuts. Let's lock this in back. What's going on? There we go. Okay. Got another. Another. And another. I mean, this thing's cool to the touch. Again, not that I would necessarily expect there to be a lot of heat generated from this. But right here, I guess this legitimately is a plug your tools into the wall, right? Like the first video maybe was a little bit clickbaitish, but this one certainly is not clickbaitish. I mean, we're running Milwaukee's Fuel 10-inch miter saw, and so far it doesn't seem like it's got a lot of problem. Like, I mean, I don't really have a lot of heavier duty stuff to try, like hardwoods. I've just got, pine 2x4s here. But the very fact that we have this, that it's working okay, is pretty impressive. So we'll get this thing unplugged here, let it die out. But yeah, this has been a pretty fun journey now. I mean, we've gone from, you know, what runs on just one of these battery packs to being disappointed. And then we started running some current testing, right? We wanted to figure out what all these different tools have. And again, I've tested, I think, most of the tools I have. If you guys are interested in seeing other current draws for other tools, let me know if I've got one. Before you do anything in here, I want to do full disclaimer, right? This is me testing out stuff on my tools. I am accepting the risk for this. If you're interested, you need to accept your own risk here. I'm not going to be liable if you screw up your tools. I was fully aware that this may not be a saw anymore. It may be a paperweight. And I was okay with that because, you know, trying to push the envelope on what you can do with tools is always a lot of fun. So, so if you have any questions, please post them below. I'm happy to answer. If you like the video, please make sure to give it a like, subscribe. I'd like this video, again, to reach as many people as possible, since I think there's a lot of promise here, especially unlocking you from having to buy Milwaukee's batteries or use third-party. You know, now you have plug-in convenience pretty much anywhere. If we can get, let's say, 100 likes, right? I don't have a huge follow base here. I think I'm, at the time of recording this, maybe 62 users. But if we can get 100 likes on this video, I will buy the M18 air compressor and we'll give that a shot. And if we, I don't know, make it to 500 likes, then I will buy the table saw and we'll try that out. As always, thanks for watching, and check back soon for more videos.